Hi everyone, this is Carlos, and today we're going to be looking at Aeolus. So, Aeolus is a Python library used for post-processing and analysis of UK Met Office Unified Model outputs. So, we're going to go ahead and hop into this Jupyter Lab tutorial. And again, you guys can find this on the Aeolus team's GitHub. So, here we go. So, physical constants. Aeolus comes with a couple of physical constants. It comes with physical constants for some planets and also general physical constants. So here we are looking at the general physical constants. So to see the constants, you can just set some variable equal to init underscore constants. These are our general constants and their units. To view those constants, say for example you want to view the water heat vaporization, you can just type in gen.water heat vaporization and simply hit enter, and this is what it looks like. Now to see the actual values, you can hit l.data, and to see the associated units, l.unit, and that will show you the value and the units. Like I mentioned before, there is some planetary constants as well. They highlight the Earth, but because this is the Exoplanet Modeling and Analysis Center, we are going to look at the TRAPPIST-1e constants. And TRAPPIST-1e is, of course, a very famous exoplanet that is in the habitable zone of TRAPPIST-1. So, to see those constants, we are simply going to type in TRAP1e inside these parentheses. And because this is already included in the package, it will pop this up for you. Again, if you want to see any of these constants, say for example gravity, you can go ahead and just type in .gravity and it will show you gravity and its units. Now if you want to see the value of gravity, just go ahead and type in .data, and that is the value of gravity. Pretty close to the Earth, pretty cool. Another cool thing with these constants is that you can do math with them. As I show here, I am dividing the general constant for molar gas divided by the TRAPPIST-1e constant for dry air molecular weight, and I simply do the math. I give it a name so that when I type it, it has an associated name with it, and to see the value, .data again, and there is our value. Another cool thing about Aeolus is that it allows you to work with model outputs. So say we have some model output. Here it is in this sample file. So let's go ahead and load in the sample file, and this is what it looks like. As you can see, there is tons of data, of metadata inside this data, which could be important. Now, we are going to use the Atmos Sim module to combine all of this data with a name and a description. So you can use Atmos Sim. You're going to set cubes equal to this input data. This is this. Cubes is where you want to put your input data. We're going to name it T1E underscore example, TRAPPIST-1e. We're going to give it a description. Here's a description. This is some sample data from a simulation of tidally-locked TRAPPIST-1e planet, and the planet's name is TRAP1e. And yes, this reads constants from the JSON file, which is from this. Here we go. Boop. This is from the JSON file. So, anyways, we use Atmos Sim and we can combine all this together. Now, when I hit my run shows all of that input data, but also, if I use constants, it shows me that this is the TRAPPIST-1e constants. Basically, I just combined all of this data and metadata together using this Atmos Sim. Again, a couple of different ways to view it. You can use myrun.cv underscore rain to see the CV rain. You can also put it in parentheses as a string. Bada bing, bada boom. The last cool thing about Aeolus is that it comes with this model module that allows you to define variables with strings. So for example, this LMDG is equal to model parentheses, and here they have set t equal to time, z equal to altitude, etc., etc., etc. And you can take advantage of this by making your own models. So for example, this is a preloaded model, this and basically with the models module, you can set whatever variable you want to whatever string you want. So for example, this is the unified model, this this is what we were just looking at. And here, as you can see, they have um.u, this is x wind, um.v, y wind, um.w, upward air velocity. And if we go over here and look for it, which we won't because it's a lot to look for, you will find that it's the same thing. So yeah, guys, that is Aeolus. If you guys have any questions, make sure to either ask us on Twitter or in the comments below. And yeah, have a great day. Peace.